Hello and welcome to the 15th unit of the Qt tutorial from tutorialcoding.com. In this unit I continue to introduce the QLineEdit class and I show you how to apply an input mask or a validator onto it. Input masks and validators are constraints that only let the user enter specific patterns and that are marked as valid. The example application consists of two entirely separate widgets, the InputMasks demonstration widget and the validator demonstration widget. These are shown and hidden depending on which radio button is selected in the top. Both contain a LineEdit, a set of input masks or validators that can be applied to the LineEdit depending on which choice is made here. A maximum length LineEdit field that is updated anytime the input mask or validator is switched. So it shows the maximum length attribute of the LineEdit field. And when this value is changed, it applies the maximum length value to the LineEdit. And then there are two signal monitors for editing finished and return pressed. The reason I added these two signal monitors is that these signals behave differently when a input mask or validator is applied to LineEdit. The behavior is that normally editing finish is emitted anytime the LineEdit loses focus, and when an input mask is applied, it only is emitted when LineEdit loses focus and the pattern that is currently in, or the value that is currently in the LineEdit matches the input mask pattern. So it's completed. If I only have a partial value there, it won't be emitted. And the same goes for validators. If I have an invalid value in there, it won't be emitted. So input masks. First, I introduce the maximum length attribute. This isn't technically part of the input mask, but it interacts with it. It sets the maximum length of the text that is allowed to be entered. So now I have a very high value. This is the default value, 32,767. Now I enter text, foobar, and now I change this value to 3, and it will truncate the text to the new value, maximum length value. And I can't enter any more characters. I can remove characters, but I can't enter any more characters. The setInputMasks method of the QLineEdit class takes a string and it applies a constraint which says each field in the input mask or each character position in the input mask can be an optional or a mandatory value. And these wildcards that specify this can be characters, numbers, alphanumeric values, any character, hexadecimal values, binary values, and constant patterns. Lowercase placeholders means the character position is optional, and uppercase means mandatory. So the 9, for example, means it's a mandatory number from 0 to 9. In this case, for the LineEdit, it means I have to enter 4 numbers in the beginning, and then another 2, and then another 2, and these are separated by hyphens, which are constant patterns. So I can enter a valid date, and when I hit the enter key, the editing finished and return pressed signals are emitted. When I remove 2 characters and do the same, these signals are not emitted because the pattern is not, or the value in the in LineEdit is not complete based on the pattern, because it expects mandatory numbers at the end too. This is of course not specifically perfect. I can enter the year 5000 and month 99, day 99, which is absolutely not valid. But it gives a basic constraint on the input, and it says there are no letters in there, so I can't enter foobar. It just won't allow me to enter any letters. Anytime I switch between the input masks, the maximum length attribute is changed So the input masks change this value depending on what kind of pattern they have. So for example, post record has 5 mandatory numbers from 1 to 9, and that means the maximum length is also 5. Removing an input mask resets the value to the default maximum length. When a value is already in the input masks, for example 2012, 2014, and I switch to an input mask. So previously I had no mask, and now I switch to it. It tries to take over the values that were previously part of the field. But if I have a previous value that absolutely doesn't match it, it just throws them away. Here I have a date pattern, a MAC pattern, which is a set of hexadecimal numbers. So it allows 0 to 9 and A to F, but not G or any other character, or exclamation marks or similar are also forbidden. And I also have a fixed pattern, which is the moon is shining. This pattern only consists of constants, so I can't enter anything. It just fills in the constant and does not allow me to do any value entering there. There were some quirks involved when I created this application. The moon is shining actually is not a constant pattern. It has 2 placeholder characters in it, the N character, which is a number, and the H character, which is a hexadecimal placeholder. And to make it a constant expression, I had to escape these values with a backslash. And because backslashes have to be escaped in strings too, I have to escape them with 2 backslashes. The other thing is not a quirk, but really a new thing that I've done here. It's converting an integer number to, no, it's converting a string to an integer number in a cute way. And the method to do this is the QString classes toInt method. So I enter a number here, and then I read the number into a QString value. And then I try to convert it with a toString method and pass a pointer to a Boolean value. And this is set according to if the operation succeeded or not. So when I have a few alphanumeric characters in there and try to convert them to int, it will fail. But if I have only alphanumeric, I mean when I have letters or exclamation marks. So when I have letters or exclamation marks in the field, it will say, no way, that's not a number. But if I have number characters in there, then it will convert them to an integer. The alternative would of course be to set an input mask on the second line edit here. That would also have been a possibility. Validation. Validation is similar to the input masks, but it has a few different attributes. And there are a set of standard validators and regex validator. So first, let's see the interaction between maximum length and the validators. When I switch between the validators, you see the maximum length doesn't change it. It has an additive interaction, so the maximum length is still taken into consideration additionally to the validator. Validators also don't emit the editing finished or return pressed signal unless the value in the line edit matches the validator's pattern. There is a class called QIntValidator and QDoubleValidator. These are used either for line edits, but also for spin boxes, and they allow to specify values between a minimum and maximum value. So IntValidator here I have set it to a value between 100 and 200. When I enter 125, it will emit the signal, this is a valid pattern. It won't let me enter any more numbers. Validators have 3 states that they return for an input. Either it's valid, so it matches the validator. It's an intermediary. An intermediary is a value that could be a valid value with some additions. For example, 12 is an intermediary. It's not valid, but I can add to it another number and then it will be valid. And there are clearly invalid patterns, for example, letters. I can't enter any letters here, or exclamation mark symbols, or any other value that is not a number is absolutely forbidden. And I can also not enter a number that is longer than the maximum value in digits. The second validator I introduce is the Q double validator, and this validates floating point numbers. This is a valid value between 100 and 200. This is also a valid value between 100 and 200. Now, validators set a locale or use the locale to determine what a valid value is. And in the United States, the customary separator between the integer, the decimal parts of a number and the fractional parts is a point. So when I enter 132.0, it will emit this is a valid value. But when I put a comma in there, it says no, it's not a valid value. On the other hand, when I set the locale for Germany, which takes a comma for a separator, it will accept this value, which is the very same value, and it didn't accept in the US locale because it just does not match the locale. Regex validators take regular expression, so these are the most flexible validators. Here I simulate a username, which is an alphanumeric character and has a length between 3 and 16. So it allows me to enter numbers and letters up to 16 characters, and then it says no more. That's the upper limit. The interaction between maximum length and the validators is that validators don't set it, but when I change the maximum length to 10, it is still applied as a constraint, even though the validator would allow a higher constraint. So I can't add any more characters in here right now because the maximum length is 10. So it really just terminates at 16 characters when the maximum length is above it. When applying or removing validators to a LineEdit, the maximum length value is not changed, so this doesn't interact with it like the InputMask did. Quirks for the validator implementation were that in the label of this radio button for the regular expression, I used left and right bracket. And when I tried to put them into the string for the radio button constructor, it first didn't display them, and second it kind of crashed on exit and did horrible things. The resolution for this is that any character that can be interpreted as something special can be escaped using the octal values. So when I created this label, or when I initialized this radio button, I use the octal value of the left bracket and the octal value of the right bracket, and I also escaped the backslash character here. So let's jump a little bit into the code. The application consists of the InputMasks demo and the validator demo classes. And these define the two LineEdits, the LineEdit that we are operating with and the LineEdit that contains the maximum value, the radio buttons that switch between the InputMasks, and two signal indicators. and it has a set of slots that are triggered when the selection between the input masks is changed, or when the LineEdit, when the maximum length is changed. Jumping into the code, the widgets are created and initialized with the label. So the radio buttons are initialized with the label. The max value LineEdit is initialized, and it reads the current maximum length value of the LineEdit. Then it creates two signal monitors and connects them to the editing, finished, and return pressed signals of the LineEdit class. This is actually done in the constructor. So it sets up the widgets, then it connects all the signals, the radio buttons for toggling the different input masks, the editing finished signal of the maximum value that changes the maximum length of the text allowed, and the editing finished and return pressed signals for the signal indicators. And finally, it toggles the first input mask, the radio date input mask, to apply the date pattern to the input on startup. So when I launch the application, the first thing selected is the date pattern. The layout basically consists of a few group boxes that are put into a vertical layout. And when one of these selection radio buttons is selected, it checks if they are selected or deselected. Then they apply the input mask that are in their labels, and then they update the maximum length LineEdit field with the current value or the new value of the LineEdit's maximum length attribute. So they read this attribute, which is integer, converted them to a string, and then applied to this LineEdit. And the maximum length changed is the same code snippet I showed in the presentation. It reads this value, converts it to an integer, and applies it to the LineEdit. Validator demo is structurally the same. It has a few radio buttons, a signal monitor's maximum length, and it's also wired the same. So it sets up the widgets and the validators. The difference here really is that the validators, instead of setting a string sequence on the input mask, it creates validator instances, which are QInvalidator, QDoubleValidator, and QRegex validator. So these are set up on startup. And when the various radio buttons here are selected, they set the validator that has instances in the class instead of simple string patterns like the input mask demo. And then they also update the maximum length field, the same as before. The main window class consists of instances of these two widgets, the input mask demo widget and the validator demo widget. And it has two slots which are triggered depending on as when the radio buttons at the top are selected. So in the constructor, it creates an instance of both of these widgets, demonstration widgets. Then it creates this upper switcher. And then it adds all these widgets to a vertical layout. So technically, the validator and input mask widget are all after each other. And it then connects the radio input mask radio button, these two radio buttons, two slots that hide or show the individual widgets. So the input mask widget here is simply not shown. It's still in the vertical layout in this application, but it's not shown. And on startup, it checks the input mask radio button. hiding the validator. An interesting point here is, or an interesting addition to the layout that I didn't use so far, is that I added a spacer at the button. And the effect of this is a spacer item that has a horizontal size policy of minimum and vertical size policy of expanding. So when I drag the widget down here, here is an empty space. Normally you would expect it to scale with the window like it does horizontally. But vertically it doesn't, because here is a spacer item and it expands and takes all the space that is being freed here. And I did this because originally these two widgets weren't of equal height, and to make them look good, I filled up the remaining space. Now the final example application has this same height for both of these widgets, so this is just an interesting quirk that was part of the development process. And then there is the signal indicator, which is just a carbon copy from the last unit's signal indicator. It's nothing new really. So this concludes the unit. Thanks for watching. As always, you can find the unit sources and notes on the tutorialcoding.com website that you can reach by clicking on the orange annotation. If you found this unit video insightful and enjoyable, please like it and leave a comment. Subscribe to my YouTube channel or follow my Google+ or Twitter feed. Goodbye.